Assalamualaikum and hi, my name is Nur Azira binti Ruzman. In this video, me and my group member will be present about our water reticulation design project for subject ECW 435 hydraulic. In this project, we are required to design a pipe network for 8 blocks of 5-story building, an admin building, and a cafeteria. Besides, we need to design a water reservoir that can cater water demand for parcel M and N, also parcel A, which shown in the figure 2. In this slide show a detailed information for our proposed pipe network layout. There are 6 drop-off points in the layout we propose. Pipe material we use is mild steel pipe with 110 roughness coefficient. Proposed diameter of pipe is 270 mm and we assume that 1-story building is 3 meter. Formula to get the top water level is elevation plus building height plus 3 meter water tank. Elevation and length of pipe are obtained directly from the AutoCAD drawing. Based on Malaysian Water Association, water demand for a building 5-story, which we consider as a flat, is 1,135 litre per day. The water demand for 1-story building which is cafe and admin block, is 2,270 litre per day. Formula to calculate water demand of block is number of floor multiplied with number of residents per floor and multiply with water demand. And to get water demand for admin and cafeteria block, area of building divide by 100 meters squared and multiply with water demand. So here is the calculated water demand for each building and at every drop-off nodes. To get total water demand, we need to total up water demand at every drop-off point, which we get 9,124,575.71 litre per day.
Now we are going to calculate for peak flow and firefighting flow calculation. First, we are going to calculate peak flow. For peak flow calculation, we need to multiply with 2.5 for the total water demand and also for each node. Then, we can label all the values calculated in the peak flow scenario like this. Next, we move on to the firefighting flow calculation. For this firefighting flow calculation, the formula used is fire risk plus with the total demand. So for this project, our group are using class B risk, which is congested area with buildings up to 5 stories. Then we calculate for average total flow and also the number of hydrants. From those values, the fire flow now can be calculated, but for the fire risk, we need to multiply it with the number of hydrants. Hence, we get the value of the fire flow. Since the value of the fire flow is larger than the peak flow value, thus the firefighting flow is used as the design flow. So this is the fire flow scenario. For HPM calculation, which is head balance method, we are using Hazen-Williams equation to find the head loss H. So these are the formula used in this equation. L is the length of the pipe in meter, D is the diameter which is also calculated in meter, and C is the roughness coefficient. By combining all the equations, we can get the final equation for head loss. Next, by using the Hardy-Cross method, the correction of the pipe flow delta Q can be determined. Hence, to find Q prime, Q plus with delta Q, and at the adjoining pipe, Q prime J equal to Qi plus delta Qj minus delta Qi. Before starting to calculate the HPM calculation, we assume the diameter of the pipe is 270 mm, type of the pipe is mild steel pipe which is MS, and the roughness coefficient C is equal to 110. So, this is the final plan layout that our group will be using to calculate the HPM calculation. We convert liter per day to liter per second, and from liter per second we convert to the meter cube per second. Next, we have already calculated and this is the value for each iteration. This is the result value for iteration 1, iteration 2, iteration 3, iteration 4, iteration 5, and lastly, we stop at the iteration number 6 as the value of the total head loss is equal to 0 and the delta Q also equal to 0 for each loop, which is loop 1 and loop 2.
This is the head loss and its direction layout at each pipe are converged for last iteration, which is iteration 6. To find residual head, we use method 1 instead of method 2. This all data required to obtain residual head, while available head is 26.25 meter. From that, we can obtain available head for each pipe by subtracting available head at reservoir with head loss at each pipe. As for residual head, it can be obtained by using formula given. Then we check whether it is greater than 7.6 or not. If yes, then our design is accepted. If not, there might be something wrong somewhere. They might occur due to low available head or pipe size need to be increased to reduce the losses.
Next is the water tank reservoir design. As the total water supply from the reservoir, which consists the water demand of parcel A, M, and N, they are used to calculate the suction and service tank. The area of the reservoir is 90 meter times width 40 meter. As you can see, this is the parcel A which we need to design water reticulation. The reservoir consists service and suction tank. To calculate the value of service tank is 2/3 multiplied by total demand, and suction tank is 1/3 multiplied by total demand, and to find the main trunk is 1.2 multiplied by total water demand.
Here we can see the description that has been tabulated into a table. First, elevation level. Second is difference of top water level and bottom water level. Next is height of reservoir from ground. Lastly is the available head of water tank. Thank you for watching.